Right, so assignment 3 is going to focus on implementing a single page application. Right? We're going to refactor what we worked on last week. We're going to be introducing the implementation of Angular applications through the use of a single page, which is going to be our index.html. This is the only page that will ever be loaded as far as the browser is concerned. Right? It'll load this one index.html page. Everything else, right, all the other pages, the login page, registration, profile, and whatnot, those will be loaded on demand and from the browsers under the covers by sending AJAX requests to the server as snippets of code that then will be downloaded to the client and will be cached by the client, okay, by the Angular engine, as opposed to what we have now that every time we go and fetch a page, it is re-rendered and downloaded brand new from the server. Okay, so there's no caching involved here. Angular is going to be doing the caching, so it's not going to have to go back to the server for any of these snippets of HTML once they're downloaded first. We're going to create various Angular views. All these pages that we worked on last week, they were. All the pages were fully functional, standalone pages, right? That could stand on their own. You could double click on them, and a browser opens up, and it shows you the content. Fully laid out, fully stylized, right? So we're gonna go away from that, and instead, these pages are gonna be more like components that can be loaded, independently, and then you can paint the page with all these snippets of HTML code, right? And you can put them anywhere you want. Mostly they're going to be full-blown content pages, right? Almost like a full page, but it's not going to have any of the head and the body, and it's not going to have any of the footers. None of the things that are common to all pages, right? So they're not going to be meant to be standalone HTML pages, right? They're going to be meant to be snippets, right, or portions of something bigger, okay? That can be loaded on demand to paint the page as appropriate. So we're not going to call these pages anymore. We're going to call them views, right? So it's a smaller context, right, where a page might be made up of several views. Okay, right? It might be the header view, maybe a footer view, maybe a sidebar view, maybe the main content view. That each one can be loaded dynamically to fill in to paint the entire page. So we're also going to have some refactoring of moving some code around. So for instance, we're going to grab all the pages, all the views that have to deal with the user. We're going to move them there. We already started this, right? We already started putting the login, the registration, and the profile. We put them on the user directory. We did that last week, right? We started already organizing a little bit around there. So same thing for the websites. Same thing for the widgets. Same thing for the pages. So we already did this first step. Right? We almost got that done. We're also going to rename some of the pages, some of these views, and we're going to follow a naming convention. So that should help us manage complexity, manage the large number of files as they grow. We have to find mechanisms that make it easier to us to find things, right? When you're looking at a file, it should help you. If you just look at the name of the file, it should already position you, place you. Where are you in the application? Are you on the client side? Are you in the middleware? Are you in the database? Where are you, right? So it's very common that you choose a naming convention for the various artifacts that we build that position you where you are. You're in the client. Okay, so we're building all these artifacts, either an HTML page or JavaScript or CSS or whatever it is. Where are you? And so from the naming, this tells you that you are writing code that is meant to be rendered, meant to be interpreted by the client, meaning on the browser. View also gives it the role of this artifact. What is it? What is it being used for? And if it's meant for consumption by a human being, then we give it the name view, right? So this artifact is meant to be consumed by a human being, right? And it's code that is being interpreted on the client side. As opposed to if this would be a PHP or JSP or an ASP, right? This might say it's page, it's a view, meaning it's meant to be consumed by a client, but it's server, meaning it's a view that is being rendered on the server. Make sense? Right. So the naming convention should allow you to position you where you are. Okay. Also, the naming convention is that the first word will say what entity, what piece of information are you manipulating? So we're manipulating either a page or a widget or a user or what it is, and then followed by what kind of what type of things are you displaying? So in this case, we're listing several pages, so a list of pages. Again, your team, whenever you're going in industry, your team will come up with a naming convention. Whatever the team decides, you should stick to whatever the team suggests, right? If you have a suggestion as a better naming convention or a better organization, certainly discuss it with the team, right? And make it a team effort to agree on how is it that you're going to organize yourselves, right? Don't just go off and name anything you want. And remember, your code is not yours, right? You're coding for somebody else. Somebody else is going to be responsible for this at some point. The source code is going to definitely outlive you. And so you want to make it easy on other folks to manipulate all their content. Okay, so we're going to have directories. We did this already last week: user, website, pages, widgets. But we're gonna create. So all of these artifacts up to this point were for displaying content to the user, right? So we're going to grab all of those, right, and we're going to put them in a directory. Views, right? Because we're going to have other artifacts that are not necessarily rendering things for the user. So, but all these things that are meant for rendering, we're going to drop them into a directory called views. Okay. Let's see. The index page will be the first page that we're going to be rendering. That's going to be the entry point. Routing. So we're going to be introducing routing, meaning we're going to remove all those hard-coded links we had before that you have. Clicking on a hyperlink takes you to an actual page. We're going to move away from that. Instead, we're going to be using a centralized controller that is going to allow us to navigate through the pages, but without actually refreshing the page. Okay? If I mentioned this last week, right, that instead of having each page knowing about each other, instead we're going to have a centralized controller. And each page is going to notify this controller and say, hey, the user clicked on login, or they clicked on register, or they clicked on whatever, right? And so they're going to notify the centralized controller of the intent of the user, right? It is then the responsibility of the centralized controller to decide where the navigation continues, right? It's not going to be the responsibility of a view to know where to navigate. It shouldn't be the responsibility of views to know about logic or navigation. Their responsibility is just to render stuff. Give me some data and I'll render it. Right? I don't know about. They should not know about navigating. So we're going to be using Angular's routing library to re-implement the navigation. Here's a snippet of code of what it is that we're going to be doing. This is Angular's routing mechanism. You map various intents, what the user intends to do. And then you map it where it should go, right? What should be rendered at some point, right? So this what this does is it's decoupling, right? That's the concerns, right? It is not the concern of the view to know about mapping. It is the concern of the controller to know about routing and navigational, all right? And this is something that we copied straight from MVC frameworks such as J2EE and .NET. These are ideas that have been around for quite a while, that have worked very, very well on server-side technologies. This is a rehashing of that same idea, but on the client side. Okay. All right, so we'll do that later today or perhaps tomorrow. Here is the routing. These are all the routing. These are the high-level intentions of the user, of where they want to be. and what do they map to? Right? So this is the logic that allows you to navigate between these two things. Let's see. Also notice the hierarchy here. Notice that these are getting deeper and deeper into the website. These first couple of routes, login, register, user, somewhat give you the starting points, right? Where first identifying a particular user. Once you have identified a particular user, different routes will allow you to navigate to data that is associated to that particular user, right? The websites that a particular developer created, right? So my websites are going to be different from your websites, right? So if I log in, I will see my website. If you log in, you see your websites, yes? So following this path, these paths over here allow you to navigate deeper and deeper into the website. So I've identified the user, so now I've identified the websites, then I can select a particular website and identify the pages for that website. If I identify a particular page, I can see the widgets of that particular page, right? So notice that that these routes, right, allow you to maintain that kind of context of where are you at any one point in the data space that is available in the website. Yes, right. And this also introduces a very important concept, at least in single page application, is that the route, right, or the URL of the application, right, should be should uniquely identify the current state of the application, right? You should be able to grab and hyperlink bookmark that URL, okay, and be able to recreate the page from whatever the URL says. Right, so identifying here a particular user ID, a particular website ID, a particular page ID, maybe a particular widget. Right? You should be able to take any one of these routes, maybe copy it and send it over to somebody as an email. They click on that hyperlink, right, and your page or your application should be able to re-render the state of the application at that particular URL context. That make sense? I mean, imagine Amazon does this, right? Amazon, all their pages are dynamic, right? As you navigate through their catalog, right? They have reviews and they have they're offering other products and so all of these things they're grabbing dynamically from all sorts of places, right? And they're generating that page dynamically. Yes? And even though it's dynamic, meaning if you come back tomorrow, that page won't necessarily look the same, right? The description might have changed, the price might have changed. Well, all things change as maybe even throughout the day, right? But nevertheless, the state of that particular page, right, is uniquely identified by the URL. You can grab that same URL, send it to someone, they can click on it, and they would see exactly the same page you were looking at, right? Even though it's dynamic and dynamically generated. So same thing, we need to be able to grab that state of the application and uniquely identify and recreate what it was when you first generated that route. And we'll see how to do that. That's a very important key, right? That whatever you want to be able to remember, right, it needs to be encoded in the URL. We're also going to create services, right? So the services are going to be responsible for hosting all the data, right? All the list of users, the list of websites, pages, widgets, right? They're going to be responsible for hosting all this data. Eventually, there's going to be hosted on the server side, perhaps in a database, right? But we don't have those just yet. Okay, the web services are going to be responsible for shuttling the data back and forth from the client, right, and from the server. Right? So this is going to be the client-side services that are going to be giving access to the rest of the data to the rest of the application. Okay, and you'll have one service per type of entity. Right? So you have one for the user, one for the websites, one for the page, one for the widgets. Right? So these will all host the various CRUD operations that you can do on any one entity. Right? So the user will allow you to create a user, right, to register them, right? Find a user by username or find a user by credentials, right? Websites also be able to create websites, remove websites, find a website by ID, update a website, right? Delete a website. So they're all going to be hosting the various CRUD operations for any one entity. Make sense? And here we're giving you some dummy data to get started, some mock data for a couple of users, Alice, Bob, and Charlie, and Janunzi, with username and passwords, first name, last name. Notice that this might be missing some attributes, maybe like email and certain other attributes. If you see that an attribute is missing, feel free to use it or add that attribute. Yes? If it's missing an attribute, add it yourself. Okay? So this is some dummy data that we're going to get started. You're free to add more, okay? But the TAs are going to grade based on this data. Right? So they're going to try it out based on this data. But if you want to make it a little more realistic, go ahead and add more things. So here's some of the API that the services are going to provide. So the services are going to be able to allow you to create a user, so you can register a brand new user. You can find an existing user if you know their user ID. If you know their username, then you can retrieve that user by that username. This is useful, to check if that username already exists. If somebody's trying to register with an existing username. Find a user by credential. This is useful for logging in, right? Is there a username and password? Right now, these username and passwords are going to be in the clear text, right, back and forth from the server. For now, when we get to security, the next to the last week, we're going to talk about SSL and encrypting passwords and all that, how to secure your website. But for now, these username and passwords are going to be clear text, right, back and forth. Yes? All right? So we'll revisit security towards the end. Be able to update a user if somebody wants to change their email, wants to change their phone numbers, their address, then you can update their user. Or you can remove a user if you want to leave the community. Here's some examples on creating a service. We'll come back to this a little later today or tomorrow. We're creating web services for each one of the entities. So here's a snippet of what the code might look like to get you started. Right, so you can create a service, then add some dummy data in here, and then the API. There's a couple of ways of creating services. This is one of them. We'll look at other ways. Notice that all JavaScript code is inside of IFI expressions, right? That create a module, right? That creates a namespace that doesn't litter any of this any function that you're creating here outside of this namespace. Okay. So I want to see IFI all throughout your source code. On the client side, on the server side, you don't need IFI statements, right? Because Node.js creates its own modules, its own namespace. So this is only on the client side. Let's see. There's a couple of website services. Again, this is some of the dummy data that we're going to be using through for grading purposes. We're going to create a couple of websites listed there. Facebook, Twitter, Gizmodo, Tic-Tac-Toe, Checkers, Chess. This is the owner, the developer that created this application. So these are developer IDs that map to users created here. Yes? So kind of like a foreign key of a piece of data that has an owner and some description. Again, some bogus description. Again, just for grading purposes for the TA. You're welcome to change. More description, more websites, but this is the minimum that the TA is going to expect. Again, some CRUD operations for websites, being able to create a website, find a website by user, meaning give me the websites created by a particular user, or give me a website if you know their ID. Update a website by ID, and you provide the new version, new data for that website, or delete the website if you know its ID. Page service, same thing. There's going to be at least these 3 pages belonging to this particular website. So again, a foreign key, right? So each page knows what website they belong to. and some bogus description. Again, CRUD operations for the pages. Yes? Okay. And finally, widgets. These are all widgets belonging to a particular page. So these are all, they all belong, these are a whole bunch of widgets that are being displayed at a particular page. There's a couple of types of widgets. Widgets of type heading, image, HTML, YouTube, and I got another HTML. And some of the data, right? So for heading, you have Gizmodo and size 2 and size 4, right? And so here's the second one is Lorem Ipsum. Here's an image. This is a random generator of images, right? To create a random list of random images. Here's a YouTube widget, and we'll learn how to do that. Here's some the API for the widget service. All right, controllers. So each one of the pages that we saw last week, again, they're going to be made into views, right? We'll see how to do that. So they're going to become snippets of HTML, and the content is supposed to be dynamic, not static. And so we need to generate the JavaScript that gives these views the dynamic content, right? The data, right? And the responsibility of shuffling the data back and forth between the view and the data source is the controller. The controller is responsible for listening for incoming events from the user as the user types or clicks or drags or whatever events they do with their gestures, right? The controller is responsible for listening to all those events, right? And notifying the services and the data sources or our model, what to do, right? Either to insert new data or retrieve our existing data or somehow manipulate that model. So we're going to be creating controllers for each one of those views, right? So the login page is going to have at least two actions, right? The clicking on the login page, right? On the login button, or navigating to the register page. Yes. So the only one that really has any business or business logic around is logging in, right? We need to take the username and password, verify that the credentials are good, and then come back and decide whether we let them in or not, right? So there's some logic associated with it. The navigation to the register page, there's no real logic there, right? I'm just going to let you just navigate to the register page. There's no logic there. So the controller for the login view is going to be listening for that click on the login button and running some logic, accessing some data using a service. So each view will have its own dedicated controller. Yes, right. And so you'll need to create controllers for each one of the views. So for instance, in the views for the user, you'll have all your templates. Oh, that's also right. Here I said optional. I'm going to remove that. We'll do that. Not optional. All our HTML, right? We're going to split them, putting all our HTML under templates, and put all our controllers going under controllers. And for each view, there will be an equivalent controller that goes along with it. So if there is a login view, there will be a login controller. If there is a profile view, there will be a profile controller. Yes? Right? Again, this is one of several ways to organize the code. This is a very popular one, where you put all the views on the templates, and you put all the controllers on the control directory. Right? And sometimes you have different teams working on different directories. Right? Where you might have the designers and the folks that know how to make things look pretty. They spend all their time under the templates directory. Right? They do all the CSS design and whatnot. And then the JavaScript developers spend most of their time under the templates. Under the controllers, right? Generating all these, all these event handlers and fetching data back and forth. Right? So all the controllers, there they are. The controllers I'm going to need, and login controller client, register controller client, profile controller client, right? So those are for the user. Then for the websites, you're going to have something similar. You're going to have definitely the HTML under templates and the controllers under controller. So there's going to be 3 views, one for the list, one for the edit, one for the new, so you're going to have templates and controllers and controllers for each one of those templates. Yes? All right. Same thing for widgets, same thing for pages, right? So we're not going to get into too much. Here's a snippet of code that to just remind you how to create controllers. We'll come back to this. We'll create plenty of these throughout the week. Yes.
Could we do it in separate folders inside the respective folders, like with widget, add a controller folder, and template?
Yes. Yeah.
Differentiated by the name.
No, they're all going to have templates and controllers. And then inside of each, they'll have 3 controllers for one and 3 templates for that entity. Okay. Well, in this case, there's 3. Your application might use many more. So at the end, this is what your directory structure might look like. What else? In the routing, in the navigational part, you need to configure, what view goes with what controller. Right? So what controller is the one responsible for rendering a particular view, to provide it the data, right, or to listen for incoming events. So we'll do that in the router, and so for instance, for this particular view, it is this particular controller for that particular view. Okay? And we'll talk about how does the view refer to the controller from within the HTML. We'll see that in a minute. Yes.
So you just said we're moving the views, like the HTML, into like views/user/template. So like up there, that
Yeah, this should be templates.
Okay, I just want to make sure.
Yep. Thank you. Yeah, I'll re-update this to make sure that it's consistent all throughout. Because last semester I made it optional. I'm gonna make it. It has to be follow this. It was hard to grade. Some folks were doing it one way. Some folks were so it was just harder on us. So I'm just going to standardize it so it's easier for us to grade you. Okay. Also, controllers to be able to refer to their views. We're going to introduce the concept of not using the scope instead of using the controller instance. I'll talk about why would you do that, what are the benefits of that a little later. Also, we'll talk about how to bind each input field to the controller so that the controller can see the data as the user types and be able to read a user input. The binding, okay, populate, edit page, form elements. Okay, this won't make sense until we actually do some Angular coding. All right, we'll come back to this a little later. Heading to the widgets. Okay, the directory structure. The deliverable for this week is as every week we ask you to create a release. And the release for this week will be assignment 3, okay? And you will copy and paste the URL to your GitHub, the URL to your hosted environment, and you will submit that to Blackboard. I think that's it. All right. All right. So let's get started. Any questions before I get going? We'll revisit this as we go forward.